You're welcome back. For as many of you that have done the assignments on the previous work on the calculation of dimension of physical quantity, I want to say kudos to you. We'll go down on the correction. But for the corrections, I quickly want to remind you that you shouldn't forget to like, to subscribe, and drop your comments. That will be a long way to assist me to serve you better. On work, power, momentum, we quickly want to do justice to the correction on the calculations of dimension of physical quantity. Firstly, we'll be looking at work. We are very much acquainted with the fact that work is force times distance. That's our step one. You have to work with the formula. The formula should be embedded down there in your heart. So what's force? Force is equal to mass times acceleration. So we represent m with a capital letter M. Acceleration, we already know we have it as LT minus 2. So we're replacing acceleration with LT minus 2. Don't forget we have distance. And the dimension of physical quantity with respect to distance is represented with an L. So we will be having M, L1, another L1, T minus 2. Don't forget that we have invisible multiplication signs. So M is multiplying L, L is multiplying L, and then L is also multiplying T. So what we will be having here is M, L, remember we have 1 and 1. So 1 plus 1 is equals to 2. So we'll be having 2 here, and then we'll have our T raised to the power minus 2. That's the answer. We quickly want to go down to power. For power, we will be having that power is equals to force times distance, all divided by time. So what do? Already we have that work is equals to force times distance. It could also be stated as force times distance, all divided by time, which we rightly have here. So what we need to do is to imbibe this fellow here and move it down here. So we'll be replacing M, L raised to the power of 2, and T raised to the power of minus 2 all over T. All we did here was picking up this person because it has a link with this. Since power is equal to force times distance, all we needed to do was to replace force times distance with this substitution being done here. So we have this, and then remember we still have the dimension T. So our final answer we'll be having here is M, L raised to the power of 2, T raised to the power minus 2, multiplied by T. This man, remember, is an invisible one. But if it's coming over here, and so it's going to be replaced with a negative sign. So we'll be having minus 1. So what we'll be having, M, L raised to the power of 2, T was stopped here. For those who are not very much acquainted with this particular mathematical theory, for those who missed out, we explained that you're owing 2 here and owing 1. So altogether, you're going to be owing 3. So we'll be replacing this whole lot with a minus 3. That's our final answer. So we had M, L raised to the power of 2, T raised to the power minus 3. A very good thing about calculation in physics is the use of some memory. And the memory we're talking about here is trying to have a high retention on what we are being taught in school. That takes us to the next question on our creations being done. Well, we have it on momentum. Momentum is mass times velocity. So, we'll be replacing our mass with an M. And remember, in the previous class, we were told that velocity will be replaced with an LT raised to the power minus 1 based on the calculation on dimension of physical quantity. Instead of going through those protocols, that was why I reminded you earlier that you needed to have a high retention. Because from the previous class being taught, you would have recalled that the dimension of physical quantity with regards to velocity was an LT minus 1. So we replace velocity with an LT minus 1. So what do we have? We have M L T minus 1. That's our final answer. So for work, we had this. For power, we had this. And for momentum, we had this. Kudos to as many that got it right. We still have another assignment that will be showing on the screen very shortly from now. We're not done yet. So in our next edition, we'll talk about a correction to that effect, while we move on to what we really have for today. So we have our speed, displacement, velocity, and acceleration. Speed is the distance traveled per unit time. Speed is the distance traveled per unit time. So we'll be having speed is equals to d over t. Distance traveled per unit time. Assuming you have a body, you have the distance represented in meter, the unit of distance is meter, and you have the time, seconds. Assuming you have a body moving in this form, if it's moving progressively, that means that the distance, the speed, is also moving in that direction. Since we have that the speed is equal to distance over time, so we'll be having a body moving from this origin, we'll be having a straight line graph, all things being equal. If we have an indication of this graph, it is a smart indication that the body is moving progressively. It's moving progressively, and it must start from the origin. It must start from the origin. Though it's a rough sketch, but the most important thing is that it's giving you a signal that the body is making a remarkable progress. So it's telling us the distance is actually moving per unit time, indicating that its speed is moving, like I earlier said. So we have that the distance traveled per unit time is the speed. Sometimes you can have a graph of this nature. It might not necessarily be a straight line graph, it might be in a curve form, but it's still an indication that it's making remarkable progress. Distance in meter and the time in seconds. So we told ourselves here that speed is equal to distance over time, and that we'll have a straight line graph, and we possibly could also have a curve as an indication that is fully represented as regards to speed. Speed is distance traveled per unit time. All right, we want to go down to displacements. It's very important, viewers, that you should understand the parameters that you'll be meeting as regards to Newton's law of motion. We quickly want to talk about displacement. Displacement. Displacement is the distance traveled in a specified direction. Distance traveled in a specified direction. Displacement, as you all know, is a vector quantity. Remember we said that a vector quantity is a quantity that has both magnitude and direction. So we say that displacement is the distance traveled in a specified direction. Having said that, we quickly want to remind ourselves about velocity. We want to talk about velocity. Velocity is a very important parameter as far as the motion is concerned. So what then is velocity? Velocity is the change of displacement. Velocity is the change of displacement. Very simple. Change of displacement. Because in physics, we are not interested on how bogus your statement is, but we are looking for specific parameters that would give us a signal that you actually know what we're talking about. So velocity is the change of displacement, and you know it must take place in a specified direction.